All right, now let's graph a complex number. We're going to graph two of them here. And now graphing a complex number is very similar to graphing just a regular ordered pair. And we might want to think of this complex number as the ordered pair 3, 6. And we're going to think of this complex number as the ordered pair -3, -2. If you can graph both of those ordered pairs, you now know how to graph complex numbers. The only difference is the numbers representing the ordered pairs represent the real part and the imaginary part of the complex number. Okay, the x-axis representing the real part, and the y-axis now representing the imaginary part. So we put I instead of y on the imaginary axis for both our graphs. So if I'm going to graph 3, 6, I'm going to go over 3 and then up 1, 2, 3, 4, 5, 6. And there is my complex number 3 plus 6i. And then -3, -2 would be over 3, 1, -1, -2, -3. And then -1, -2. So it would be right there. So now 3, -2i is graphed in that position, and 3 plus 6i is graphed in that position. So the first one in the quadrant 1 and the second one in quadrant 3. Very similar to the XY coordinate plane. So now we need to discover what is the actual modulus of this. So modulus just means the distance from the origin. So if I graph 3, -4i, I would go over 3 and then down 1, 2, 3, 4 right there. And now the distance from the origin would be this distance right here. So in order to calculate that distance, because we can't just count on this rectangular grid, we can't count at diagonals, we're going to use what's called the Pythagorean theorem. And I believe you have been exposed to it and have used it in geometry, where we know now where one length of my right triangle, it doesn't matter where you make this right triangle as long as you make a right triangle, one length is 3 and the other length is 4. Okay, we can call this -4. It is the direction of it, but we would know that it's not a distance. It's just a -4 represents a direction of that side as well. So in order to find what's called my hypotenuse, or the distance from the origin, the Pythagorean theorem says a squared plus b squared equals c squared, where a and b are the legs of your triangle, and here that would be 3 and -4. And then c would be the distance from your origin, which is also called the hypotenuse. So just performing this calculation, we would have 3 squared plus, now I'm going to put -4 in parentheses, because if you type -4 squared without parentheses in your calculator, you're going to get a -16. But we all know that -4 times -4 gives you +16. Okay, so these are all equal to c squared. So I have 25 equal to c squared. And I'm going to square root this to get c equals 5. Now normally when we solved quadratics using the square root method, we would get plus or minus 5. In this case, for this particular example, we're just looking for a distance. We're not really considering whether it's positive or negative, so we're only taking the absolute value of it. So you will often see it written like this, 3 minus 4i. And these absolute value bars, this also means find your modulus. Okay, so you would graph that or just do 3 squared plus -4 squared to find your last length. So now here, the length of my complex number from the origin, or the distance from the origin, will be 5. So there is how to graph complex numbers and also how to find a modulus of any complex number.